Assalamualaikum and hi everyone. My name is Daniel Fakhri bin Abdul Aziz, the leader of Group 2 in subject BFC 35403 Geotechnical Engineering 2. This video is a review of problematic soil and ground improvement liming application on acidic soil. But first of all, let me introduce to you my group members. We have Mustakim, Intan Afiqah, Norlidyana, and Nurul Izzah. These are the contents in this video: introduction, case study, application of liming, conclusion, and recommendation. First, we will talk about the introduction. Soil acidity is caused by a combination of causes including nutrient deficits and toxicities, low activities of helpful microorganisms, and restricted plant growth which reduces nutrient and water absorption. Soil pH below 5.5, aluminum may be concentrated enough to limit or stop root development. The lower the pH, the higher the soil acidity. For your information, plants cannot absorb water and nutrients, stunted, and exhibit nutrient deficiency symptoms would be the result if the soil acidity is high. It is important to adjust and manage the acidic soil to improve crop production using different mechanisms. Lime is the primary way of reducing soil acidity because of its very strong acid neutralizing capacities. Removing existing acid stimulate biological activities and reduce toxicity of heavy metals. When lime is incorporated into the soil, calcium and magnesium ions displace hydrogen, ferrum, aluminum, manganese, and cuprum ions from soil adsorption sites, resulting in a rise of soil pH. Lime also provides large quantities of calcium and magnesium, depending on the type of liming materials used. In other words, it helps to improve the soil structure.
Assalamualaikum and good day. My name is Norlidyana and I will be presenting the case study. To begin my presentation on case study, I will explain a little bit about soil pH. An excellent chemical indicator of soil quality is the soil pH. By liming to adjust pH to the levels needed by the crop to be grown, this was done by farmers to improve the soil quality of acid soil. Soil pH is actually a measure of the number of hydrogen ions in the soil solution. However, the actual concentration of hydrogen ions in the soil solution is actually quite small. In example, a soil with a pH of 4.0 has a hydrogen ion concentration in the soil water of just 0.0001 moles per liter. To work with numbers like this, it is quite difficult. Therefore, pH is expressed as the negative logarithm of the hydrogen ion concentration, which results in the subfamiliar scale of pH ranging 0 till 14. Because the pH scale employs the use of logarithms, each whole number change, for example, from 5.0 to 4.0 represents a 10 times increase in the concentration of hydrogen ions. In addition, note that as the amount of hydrogen ions increases, pH decreases. A pH level of 7.0 will have a hydrogen ion concentration 100 times less than a soil with pH level of 5.0. This table shows the descriptive ranges for pH in soil. It shows ultra acid at below 3.5, slightly acid 6.1 to 6.5, neutral 6.6 to 7.3, very strongly alkaline at above 9.0. Liming benefits. Liming increases soil cation exchange capacity also as reduced leaching of basic cations, particularly potassium. Second, provide an inexpensive source for calcium and magnesium when these nutrients are deficient at lower pH. Third, improve symbiotic nitrogen fixation by legumes. Fourth, improves nutrient availability so plants have a better nutrient supply. Fifth, it also enhances the availability of phosphates and prevents molybdenum deficiency. Sixth, in addition, it also promotes the activity of earthworms and nitrogen-fixing bacteria as well as the breakdown of organic material that release phosphorus sulfur, nitrogen, and microelements. Lastly, the plants that might grow on the soils develop a healthier roots because they are exposed to less potentially toxic aluminum. Lastly, for case study is the importance of the finest in liming materials. The time taken for the soil to react with the liming material depends a lot on the particle size of the liming materials. The finer the particle size of the material, the faster it reacts with the soil. Take note that even the most finest liming material would take up 2 to 6 months to really react with the soil and produce a significant rise in the soil pH. Every liming material contains a mixture of different particle sizes. Limestone that which has passed through 100 mesh sieve, which is approximately have hole size about 0.7 mm square of an inch, will take up 4 to 6 weeks to react with soil acid if thoroughly mixed with the topsoil. Liming materials that pass through a 40 to 50 mesh screen may take 12 to 18 months to completely react with the soil acids. Furthermore, materials that pass through 20 to 40 mesh range will have reacted only 60% in 3 years, and materials that pass through 10 to 20 mesh material only reacted by 30%.
Hello, my name is Nurul Izzah binti A. Manja. I will present about application of liming. Liming is the most economical method of ameliorating soil acidity. We can improve the soil quality of acid soil by adjusting pH to the level needed by the crop to be grown. Increase nutrient availability, improve soil structure, and increase infiltration rates are all advantage of liming. Soil acidity. When level of hydrogen or aluminum become too high and the soil become too acidic, the soil negatively charged cation exchange capacity become clogged with the positively charged hydrogen and aluminum, and the nutrient needed for plant growth are pushed out. Next, soil also become acidic because calcium and magnesium leach out. Because hydrogen is added to soil by decomposition of plant residue and organic matter, or because nitrification of ammonium occurs when fertilizer or plant residue are added to the soil. Soil acidity has negative impact on fertility, biological activity, and plant productivity. Soil for liming method. Understanding soil pH is essential for the proper management and optimum soil and crop productivity. The optimum pH range for most plants is between 6.0 to 6.5. To avoid aluminum and manganese toxicity problem, a soil should be limed if the pH is less than 5.4. Soil with a high clay and organic matter content will require a greater amount of limestone to neutralize acidity than a sandy soil in a clay content and organic matter. A sandy soil needs to be limed more frequently because of its lower buffering capacity than a soil with a higher in a clay and organic matter. A soil that is poorly drained required less frequent liming than a well-drained soil because of the reduced leaching of basic cation under poorly drained condition. That's all
Soil
for me.
pH determination. There are 3 main internationally accepted methods available for measuring soil pH. All of them rely on shaking or stirring soil with a solution for 1 to 2 hours and then determining the pH of the resultant soil slurry. First, you need to weigh out 10 grams of soil into labeled 50 ml plastic vials. Second, add one of the following 3 solutions. The first solution is 25 ml of distilled water. This is the simplest method and normally okay for most soils. It doesn't remove hydrogen from the exchange sites and is not very good for soil with high salt content. Or 25 ml of 1 mkcl used to mask differences in soil salt content. Useful if determining exchangeable cations, as both cations and pH can be done on the same sample. It does displace hydrogen from the soil cation exchange sites, so the results are usually slightly lower than obtained with methods A and C. Or we can use the last solution, which is 25 ml of 0.01 mCaCl2. This is an intermediate between methods A and C and masks small differences in the soil salt content. Third step is shake for 1 hour at room temperature, which is 25 Celsius. Then let the salt settle for a few minutes and measure the pH after a 2-point pH 4 and pH 7 calibration of the pH meter. Next, normally 2 replicates are performed for each soil sample. Field moist soil stored at 5 Celsius should preferably be used. This procedure is to determine lime requirement. First, you need to weigh 10 grams of salt in each 6 plastic vials and add in distilled water and 0.04 and 0.02 m calcium hydroxide solution according to the volume ratio in the table below. Next, shake the vials for 30 minutes and let it settle down for another 30 minutes before pH is measured. Draw a graph of pH versus ml 0.04 and 0.02 m calcium hydroxide on a graph paper and determine lime requirement for the soil if we want to raise its pH to a certain level.
Hello and Assalamualaikum. First of all, I would like to thank you to my fellow friends because giving me a chance to make my conclusion and recommendation. For my conclusion, soil acidity become most common problem for every region. Soil became acidic when pH reading is below 5.5. As we know, the liming method is commonly used to reduce this acidity in soil. Exists another method to use for this problem? Unfortunately, this is no other solution for this problem. So, to reduce this problem, we should prevent it so we don't need to do a treatment. There is 4 major reasons for soil acidity. First, rainfall and leaching. Secondly, acidic parent material. Third, organic matter decay. And lastly, harvest of high-yielding crops. These are some solutions for liming method. For my recommendation is using granular sulfides. Granular sulfide is the slowest and cheapest method attempting to lower the soil pH. This method must avoid plant injury, so don't exceed 2 pounds of sulfur per 100 square feet per application. Wait at least 3 months to make another application. For second solution is aluminium sulfate and iron sulfate. Aluminium sulfate and iron sulfate react more quickly with the soil than elemental sulfur. However, aluminium sulfate and iron sulfate must be applied at a 5 to 6 times greater rate. Do not apply more than 5 pounds per 100 square feet of aluminium or iron sulfate at any one time. Excessive amount of these 2 sulfates can also injure plants. To reach the best soil naturality, the soil pH should be 6.5 to 7.0 range. Wood ash will also raise the soil pH and make the soil more alkaline. Do not apply wood ash, limestone, hydrated lime, or other liming material to alkaline soil. Modifying a soil pH is usually a slow process and may require repeat treatment. It is often most effective to use a combination of treatments. However, don't expect a quick fix or a miracle cure. So that's all from my conclusion and recommendation. Lastly, I would like to thank you to our lecturer, Dr. Felix, Ling, and Ling, for giving me a chance to make this slide video. So thank you.